Example 1. An electrical light circuit in John's welding shop had a load of 2,800 watts. He changed the circuit to 10 150 watt bulbs and 6 100 watt bulbs. What fraction represents the comparison of the new load with the old load? So, we want a comparison of fraction representation of new load to old load. So, that means new load goes on top over old load on bottom. When you're doing a fractional comparison, the first thing goes on top, second thing goes on the bottom. We can see the old load very obviously is 2,800 watts. Had a load, so that's old. So 2,800 watts goes on the bottom. Now the new load circuit that we're going to be using now has 10 150 watt bulbs and 6 100 watt bulbs. So can anybody take a guess as to how we're going to find the load on this? Go ahead, Maverick.
Because this is 10 150, you just times 10 with 150,
Okay.
and then 6 with 100, then add them together when you're done.
So 10 150 watt bulbs, so 10 times 150
1,500.
represents the amount of load on that, and then 6 100 watt bulbs, so 6 times 100, so 150 times 10 is 1,500. 6 times 100 is 600. Add them up, we get 2,100. So the new load is 2,100 watts. Okay, so the new load is less than the old load, more energy efficient. That's good. So first off, it's a ratio, and typically when you have a ratio of the same type of thing, the units don't matter. It's just a it's a numerical ratio. The units kind of cancel out. And I do want it always reduced to the lowest terms. Zeros on the ends are easy to deal with. Start there. So 1 0 on the end, chop it off. Second 0 on the end, chop it off. So now we're at 21 over 28. Then we're looking for single digit numbers that evenly divide those numbers. So what single digit number evenly divides 21 and 28? 7, right? So we simply divide the top by 7 and divide the bottom by 7. 21 divided by 7 is 3. 28 divided by 7 is 4. So the fractional representation to compare the new load to the old load, the new load is 3/4 of the old load.